Perhaps the most important thing about a house in Nepal, or any structure, is that it is earthquake resistant. Keep in mind that it is not possible to make any building 100% earthquake proof, but there are some strategies we can follow when designing a house to help it perform better should an earthquake occur, and ultimately limit the damage as much as possible. Here are a few rules of thumb we followed that will help to improve the earthquake resistance of our village home design. First, we decided to place our house on flat ground because flat ground is much more stable than sloped ground. Second, we used symmetric geometry and avoided having any irregular shapes or rooms that are too long or thin. We also used diagonal timber members so that earthquake forces can be resisted, designed a proper connection for our house to its foundation, and used a lightweight roof. The materials and structural system we used were partly inspired by research, but also largely guided by some of the designs created by Nepal's National Reconstruction Authority, which are available to anyone on the internet. For example, our house design uses very similar foundations to the timber design from the catalog, and our design also has the commonly used wooden truss and corrugated steel sheet for the roof structure. Another key point is that if mud and stone are properly reinforced, then they are perfectly safe materials to use in walls for an earthquake-resistant house. Where the NRA has used bamboo or steel to reinforce the mud and stone, we have chosen to use timber. The idea behind the Daji Dewari system is that there is a wooden frame for supporting the weight of the building itself, as well as everything else inside it. The closely spaced frame allows for there to be a lot of diagonal timber members between the gaps. These diagonals are the primary way for resisting earthquake forces. Then, the triangular spaces between the diagonals can be filled with mud and stone. The mud and stone infill helps to absorb energy from the earthquake and helps to protect the diagonals and timber frame from damage. The timber frame is designed to act as one continuous unit by using special interlocking wood connections held together by nails. The roof is also a timber frame, but instead of using mud or stone, it uses corrugated steel as a cover.